Good morning, my YouTube viewers. It is Crystal here, and I wanted to make another video for you. And basically, the video is a code review, and we're going to be using the TextBlob library in Python to do that. And basically, what this TextBlob does is it will correct spelling. And basically what happened is I was looking on LinkedIn and someone had put a variation of the code on LinkedIn saying that that TextBlob will correct spelling. So I wanted to see if it was correct, if it actually would do that. So I slightly modified the code and I put in a sample text and I put in what the text should be, and I wanted to see if TextBlob actually would correct the spelling. So basically what TextBlob's is a Python library for processing textual data. It provides a simple API for diving into common natural language processing tasks such as part of speech tagging, noun phrase extraction, sentiment analysis, classification, etc. And what we're going to do is we're going to use the correct spelling part of it. So we'll go through the code. From TextBlob, import TextBlob, and then we're going to create a function and say def correct spelling, and it's going to take text as an input in the form of a string. TextBlob equals TextBlob text. Corrected spelling equals TextBlob.correct. Return corrected spelling. So the sample text is something that's true to my heart because I need to get some updated technology. My current laptop is definitely 4 years old, and I need some more technology. So I wrote in the sample text, I am looking forward to getting a new tablet because my current technology is getting old. And what the text should be is I'm looking forward to getting a new tablet because my current technology is getting old. And then so we're going to print the sample text and then also print the length of the sample text and print the length of what the text should be. Sample text is 86. Text should be is 90. So corrected text equals correct spelling in sample text, and then you print the corrected text, and it's I am looking forward to getting a no tablet because my current technology is getting old. So that's pretty good. It's not an exact corrected spelling, but it corrected a lot of the spelling mistakes that I intentionally put into the sample text. So now what we're going to do is we're going to compare the correct text with what it should be, and we're going to use sklearn to do this because I don't know if you know this, but sklearn has a natural language processing facilities. So corpus equals string corrected text, comma, string text should be. And then we're going to input pandas as PD from sklearn.featureExtraction.text import TF-IDF vectorizer. But before I do that, I'm going to tell you what a corpus is. A corpus is a collection of written text, especially the entire works of a particular author or a body writing on a particular subject. And you need to know, I'm going to tell you what the TF-IDF vectorizer is. TF-IDF stands for Term Frequency Inverse Document of Records. It can be defined as a calculation of how relevant a word in a series or corpus is to a text. The meaning increases proportionally to the number of times in the text a word appears, but it's compensated by the word frequency in the corpus or data set. So that's what your TF-IDF vectorizer does. So vectorizer equals TF-IDF vectorizer. TRSFM equals vectorizer dot fit transform corpus. PD data frame TRSFM dot to array. Columns dot equals vectorizer dot get feature names out. Index is corrected text, and then text should be. So it's going to compare the corrected text with what the text should be, and it's going to put that into a data frame. And now we're going to use sklearn's cosine similarity to check what's the difference between the corrected text and what the text should be. So cosine similarity is the measure of similarity between two non-zero vectors defined in an inner product space. It is the cosine of the angle between the vectors being the dot product of the vectors divided by the product of their length. The cosine similarity always belongs to the interval -1 to 1. And this is your dot product. The dot product or scalar product is an algebraic operation that takes two equal length sequences of numbers and returns a single number. The dot product is the sum of the products of the corresponding entities of the two sequences of numbers. So now you know what dot products are. And so from sklearn.metrics.pairwise, import cosine similarity, similarity of text, sklearn equals cosine similarity, TRSFM, the first column, the first row, and then TRFM, the second row, and you get a similarity of 77.99%. Now, what I wanted to do is I wanted to do cosine similarity using just NumPy. So we use cosine similarity using sklearn, but you can also use cosine similarity using just NumPy. So import NumPy as NP from numpy.linalg import norm. And then def cosine similarity accepts string 1 and string 2. List 1 equals string 1 dot split. List 2 equals split string 2 dot split. All words equal set list 1 plus list 2. Vector 1 equals list 1 dot count word for word in all words. Vector 2 equals list 2 dot count word for word in all words. Cosine equals np dot vector 1 comma vector 2 over norm vector 1 times norm vector 2, and you're going to return the cosine. So the string 1 is the corrected text and string 2 is text should be. And when we use NumPy's cosine similarity, you have 88.89% accuracy, which is better than sklearn's, but I think that if you are dealing with natural language processing, it might be better to use sklearn's cosine similarity because sklearn's TF-IDF vectorizer is designed specifically for natural language processing. And then what I did with this was actually numeric, but I just modified it to make it strings. So I think that sklearn might be more accurate than NumPy, but I wanted to give you two ways to do it, one with sklearn and one with NumPy. And now what we're going to do is we're going to talk about jaccard similarity. Jaccard similarity is a measure used to compare the similarity between two sets. It is calculated as the size of the intersection of the sets divided by the size of their union. A value of 1 indicates complete similarity. The formula is J x comma y equals x intersection y over x union y. And that's the formula for Jaccard similarity. So, and now what we're going to do is we're just going to, and then that gave you a 76% accuracy, which is slightly better than, no, it's slightly worse than the cosine similarity when we were using sklearn, and a lot worse than cosine similarity when we were using NumPy. So now we're just going to compare the same test. I'm not going to go over the code again because it's just exactly the same code, but it's just comparing the same test just for your reference. And you can see that if you're comparing the same test, it should be 1 or 100%. So with cosine similarity, you've got 1 for and then for jaccard similarity, you've got 1 as well. So then what I wanted to do is I wanted to compare the sample text to the corrected text. And this again is exactly the same code. I'm just wanted to do it just for fun, really. And when you compare the sample text to the corrected text, it's a 30%. And with cosine similarity, using NumPy only, it's 53%. So you'll notice that you get a better cosine similarity when you're using NumPy. And with jaccard similarity, it's 40.9%. So we've got some other tests that we can do. And so I decided to use the levenstein distance. And the levenstein distance is a string metric for measuring the difference between two sequences. The levenstein distance between two words is the minimum number of single character edits, insertions, deletions, or substitutions required to change one word into another. So now we've got levenstein distance, and it gives you a 3. And that means you would have to have 3 edits or deletions, edits, to change it into another word. We've got cosine similarity with SciPy, and I'm not going to go over that code. The reason why is because you have to load an API of model to vec Google News 300, and I didn't want to load the API, but the code is there. If you want to see it, you can see the code. And then we've also got transformers, BERT and transformers. Again, I'm not going to cover that because you have to preload BERT and transformers. So we're not going to get into transformers on this particular video, but transformers are there to use for natural language processing. And it got an 83% when you compare the sample text with what the text should be. So that's it. That's it for TextBlob. So you can see how accurate TextBlob is. Unfortunately, I don't have any visualization for you, but I suppose if I had wanted to, I could have visualized it, giving you a bar chart or something like that, but we don't have a visualization in this video. So I'm going to conclude the video because we've gone over the code review. If you like my video, please like and subscribe, and I look forward to communicating with you in the next video.